red dot. All right. So, hello again, chemistry. We're here after C day or on C day, whatever it's C-ish day. Um, Hopefully, these two numbers or those two numbers way over there, those are the numbers that you remember trying to put into scientific notation or take out of it. So if I'm looking at this right here, the decimal place would be here. I would have to move it 1, 2, 3 spots. So this should, in scientific notation, look like 2.566 times 10 to the third, and it is a plus 3 because my number is larger than 0. This is in scientific notation. So in order to do this, I have to take this decimal place and move it 4 spots. Because my exponent is negative, my original number is smaller than 1, so I need to move it 4 spots to the left. So I need to move it 1, 2, 3, 4. So I'm going to have 0, 0, 0. So this should be 0.00025. There's the original number. Alright. Now again, there should have also been the excess of examples. If you have questions on scientific notation, let me know, but I think that people were pretty much okay there. What I'd like to do is finish page 3 of the notes, because you have a quiz coming up on your D-Day, right? It's on pages 1 through 3, and hopefully I've reminded you enough times. It'll just be calculation stuff, dimensional analysis. Can you do unit conversions? Scientific notation, can you put things back and forth into scientific notation or out of scientific notation? And the last bit is right here. It's something called Sig Figs, right? I will very often abbreviate significant figures to just Sig Figs, right? Oh goodness, Sig Figs right here. So significant figures are, I hate to say this, but they're the important part of a measurement. You're going to be taking a bunch of measurements this year, but not all the parts of the measurement are as important as other parts. So the certain digit and the estimated digit of a measurement are together called the significant figures of the measurement. It's a very formal definition. All it means is that we count some of the numbers with more weight than other numbers in order to determine how many of the numbers, which of the numbers are significant. There's one rule that you have to remember. I had to remember about 8. If I had this 1, I could have just done this 1 and called it a day. The rule requires a minimal amount of knowledge about a map of the United States. All right, it's called the Atlantic Pacific Rule because of the map of the United States. Now, to determine the number of sig figs in a measurement, view the given measurement as a map of the United States. Go over here, my whiteboard, and I am going to write down a number. The number that I'm going to write is 0.00225. Right? Now, superimpose onto this number a map of the United States. All right? The East Coast is over here. The West Coast would be over here. On the East Coast, we have the Atlantic Ocean. Right? We're in the midst of Atlantic Ocean hurricane season right now. On the West Coast, we have the Pacific Ocean. We're in the midst of wildfire season, which I guess is unfortunately a lot of the time on the West Coast. But anyway, Atlantic on this side, Pacific on this side. It's going to be important in a second. If a decimal point is present, what we're going to do for this rule is take attendance. Is there a decimal point? So if there's a decimal point present, think P for present, P for Pacific. That's what this is here, Pacific, right? And then we start counting at the first non-zero digit from the Pacific side, and we count it and everything else. So what that means for this section here, there is a decimal point present. Taking attendance, it's present. So we start counting on the left side. You don't need to start counting from the decimal place, just start counting from the left side. So the left side is where the decimal is where to start counting if you have a decimal place. Now, I'm going to start all the way over here. I'm going to find the first number that is not 0. So this is the first number that's not 0. I'm going to count this one and everything over. That's 1, 2, that's 3 Sig Figs, right? The trick is to find, is the decimal place there? That tells you which side of the number to start counting from. In this case, it's present. Start on the left, work your way over. Find the first number that's not 0, and just count everything over. In the example in your notes, 0.0093077 has 5 Sig Figs. So the decimal point is present. I'm going to start on the left. I'm going to ignore these because they're not 0, or they are 0. But this number is not 0. I'm going to count this number. I'm going to count this 9 and everything else over. 1, 2, 3, 4, 5. It has 5 Sig Figs. If you've heard people from this class say that counting is hard, this is why. Wish I was kidding. Alright, if the decimal point is absent, if there's no decimal place, A for absent, A for Atlantic, we're going to count from the right side. We're going to do the same thing. Find the first number that isn't 0 and start counting it and everything else over. So this number here, 2040. There's no decimal place, so I'm going to start from the right side. This is 0, I'm going to skip it. But right here, this number, 1, 2, 3. This number and everything over is significant. That's why this has 3 Sig Figs. If I were to do another example, I might do something like, what has happened? There we go, sorry. I might do 22,000, right? There is no decimal place. So I'm going to start from this side, from the Atlantic side. I'm going to look for the first number that isn't 0, which is right here. And I'm going to count it and everything over. So this number has 2 Sig Figs. Alright, actually counting Sig Figs isn't too bad. The trick with Sig Figs is that we are going to start to use them to do our rounding. Right? These practice questions should be fairly straightforward. If you have questions as to why any of these are the way that they are, let me know. But Sig Figs and Calculations, the important part is this first part. If you have two measurements that are multiplied or divided by each other, then your answer can only have the lowest number of Sig Figs. And what I mean by that, I'm going to use this exact example. I'm going to walk through it over on the whiteboard. So just give me a second. 2.3, 7.45. All right. So let's get a little more blank space. Let's go 2.3 centimeters times 7.45 centimeters, and it equals some number of things. Now, if I look at this number, it has a decimal place. I'll start from the Pacific side, from the left side. I'll find the first number that's not 0. I'll count it and everything over. This number has 2 Sig Figs. Let me make that decimal place a little more obvious. 7.45 has 3 Sig Figs. So I'll do the math. The math is really done for me. 17.135. So this equals 17.135 centimeters squared. Now, another important thing is that you can do math with numbers, but don't forget, just like in dimensional analysis, do math with the units. Centimeters times centimeters gives me centimeter squared. Now, my answer, if I look at it, this is a number that has a decimal place. So I'm going to start from the Pacific side. I'm going to find the first non-zero, count everything over. This, oop, that's not where I wanted to write. This has 5 Sig Figs, but I don't want that. This measurement had only 2 Sig Figs, so I need to turn this into 2 Sig Figs. The way that I do that, I look at my number. I see it has a decimal place, present. I'm going to start over here. This is the first sig fig, this is the second one, so I need to round to this spot. Normal rounding rules apply. This 1 does not change what this is. So in order to make this 2 sig figs, I need to round this number to 2 sig figs. I would say that it's simply 17 centimeters squared. That is a rounded answer to the correct number of sig figs. And if we look at our example question, 17 centimeters squared, answer must have only 2 sig figs. All right. I'm going to do 2 more examples, and then I'm going to ask you guys to do questions 3, 4, 5, and 6 on the top of page 4. Right, and I'll check in with those first thing on D-Day, before the quiz. All right, the example, one more example that I would like to do is, I'd like to do a division. So I'd like to do 17 centimeters divided by 50 centimeters. I'm going to do a slightly different version because this is the Atlantic version of the rule because there are no decimal places. If I look at the top number, it has 2 sig figs. If I look at the bottom number, it has only 1 sig fig, which means that my answer, after I do all my math, can only have 1 sig fig. So if I do my math, 17 divided by 50, centimeters divided by centimeters, now centimeters in the top, centimeters in the bottom, they cancel. My answer is going to be just a number, 0.34. But this number has 2 sig figs, so I need to make it 1. I will simply round it to 0.3. That has exactly 1 sig fig. Easy peasy so far. The last example I'm going to do will show you what to do if you feel like you can't get to the correct number of sig figs. And the example that I'm going to do is 0.32 times 100. I'm going to leave units blank here because I'm more focused on the numbers. If I look at 0.32, you should find that there are 2 sig figs. If I look at the number 100, you should find that there's only 1 sig fig. The reasoning for those: 0.32 has a decimal place. I'll start from the Pacific side. I'll go find the first number that's not 0, count it and everything over, that's 2. 100 has no decimal place, it's absent. I'll start from the Atlantic side, from the right side, find the first number that's not 0, count it, and it's the only one, so 1 sig fig. Because I'm multiplying, my answer can only have 1 sig fig. So let's do some math. 0.32 times 100. No, sorry. I apologize. Change in this number. It's 3.2. It doesn't change the number of sig figs, when I did this in class, I used 3.2 times 100. So, when I do this math, I get 320. And if I look at this number, decimal point is absent. Start from the right side, Atlantic. Skip the first non-zero, 1, 2. This is 2 sig figs. But I can only have 1. Now if I'm doing the counting like normal, I might count to this. This is my first sig fig. This 0 does nothing to it. It's 320, and I still have 2 sig figs. If it's unclear how to round to an appropriate number of sig figs, turn your answer into scientific notation. That's why we did scientific notation before this. So I'm going to turn this into scientific notation. The decimal place would be here after the 0. I'm going to turn this number into... Okay, hang on. Let me clean this up just the tiniest bit. This is 320. I'm going to take the decimal place and I would move it over to here. So my number would look like 3.2 times 10 to the something. I moved the decimal place over 2 times. And this number is larger than 0, so this is my number in scientific notation. Right? The scientific notation number right here still has 2 sig figs, but I can very easily round this to 1 sig fig. This is Pacific. Start from here. Here's my first sig fig. 2 does not change this. So, if I'm looking at this, so this step was scientific notation. This step is sig figs. If I go from there to 3 times 10 squared. That's my answer, rounded to an appropriate number of sig figs based on how many sig figs were in my measurements. Alright. I know that was a lot, but we did it in class. Here's the recap of it. On page 4, number 3, 4, 5, and 6. Okay? Some of them might be like this one, where it's just go from a large number of sig figs down to a small one, fairly straightforward. Some of them might be division. Some of them might be like this, where you have to go to scientific notation and then go to the appropriate number of sig figs. As usual, if you have questions, email me. I will do my best to explain through email. If not, I will see y'all on D-Day. Alright? Ooh, that sounds a little ominous. I'll see you on D-Day. It is what it is. I'll see y'all next time. Take care, kids.